reassessments today and tomorrow. You need to have done your homework in order to do that. And I just want to make sure the reason for that is not to be punitive. It's not to make you have to jump through hoops. Honestly, the homework should be done throughout. So it really, number one, should not be a big deal. And number two, that's how you make sure you know the stuff for the check-in, right? That's the reason for it, okay? Monday or Tuesday or Wednesday this week. And again, let me know if you have questions. That's the first thing. 7.2, that's the one that we are assessing today. So 7.2 standard says I can apply the relationship between wavelength, frequency, and speed of a mechanical wave. So do you know how to deal with that equation? And also knowing what happens when a wave encounters a new medium. So you've got transmission, some of that wave is going to go through, what's going to happen to that, and the reflection. Some of the wave is going to bounce back, what's going to happen to that. And that part does include that whole idea of an echo that we did in the sound waves lab, in the speed of sound lab. Okay? If you've done your homework from 7.2, then the 7.2 check-in should be pretty straightforward. I know that in some ways the last couple of months I've kind of jumped off of the homework bandwagon because we've been focused on lots of other things, but I want to refocus you and remind you, especially in the spring when things kind of get a little bit crazy. I get it. The seniors in here are antsy, the juniors are antsy to be seniors, and we're all antsy to be at spring break in summer. I get it. But we do have a lot of physics left to do. The homework is going to keep that focus for you and for me so that we can all make sure that we get through that material. Okay? So that's happening today, that check-in. We're going to do a warm-up problem and a little bit of notes before that, and then we'll check in. Wednesday, Thursday, Friday of this week, we will be doing a lab related to 7.3, which is what we're going to start today. We are not going to assess the 7.3 standard before break, but the lab will be assessed, L1 through L4. So we're going to design it tomorrow. We'll collect data on Thursday, and then we'll do our data presentation and analysis on Friday. Okay? If you know that you will be gone at some point during the rest of this week, please make sure that you check in with me or check in with Mr. B so that we know and we can work around it so that we know what's going on. Okay? Questions that you have about logistics of all of this before we get started? All right. We are going to start with a warm-up problem. So go ahead and get your notes out or get your warm-up problem sheet. Wherever it is that you write these warm-up problems, again, reminding ourselves that we're trying to stay true to our process together. Here is the warm-up problem. I'm going to give you just a couple of minutes to take a look. You do not need a phone out today for anything that we're doing. So go ahead and put those away. You've got your notes out or your warm-up sheet out. Go ahead and have a conversation with your teammates about this question right now. Probably need to read it first, don't you? Go ahead and do that. All right, physicists. Here we go. Two pulses travel toward each other along a stretched spring as shown. Pulse A is wider than pulse B, but not as high. The question asks, is the speed of pulse A larger, smaller, or equal to the speed of pulse B? There's actually a fourth choice, right? The fourth choice is there's not enough information. So you got four choices. I want to make sure that everybody is going to express an opinion, whether you're feeling really strongly, yes, I know the answer, or I think this is right. So take a look. You've had some time to talk. You're going to vote for one of those four. Are you ready? Okay. So raise your hand if you think the speed of pulse A is larger than that of B. Okay. I don't see anybody up for that. Raise your hand if you think that the speed of pulse A is smaller than pulse B. No takers. Raise your hand if you think that the speed of pulse A is equal to the speed of pulse B. Okay, that's a lot of hands, but I want to make sure, is anybody saying that there is not enough information to tell? Okay, I see a couple of hands for that. All right. Okay, so we got two different things to discuss. I'm just going to make sure that I write this down so I don't forget that you're saying that larger than and smaller than are not accurate. Can I ask you, because in another class I had a lot of people vote, bless you, vote for smaller than. What do you think they were really voting on if they said the something of pulse A is smaller than B? Yeah, if you were answering the question of amplitude, then we would say that A is less than B. That's not what we're talking about, is it? We're talking about the speed. So I saw a bunch of people with hands up that said, yes, I think it's equal. And then I saw a number of people that had their hands up for, there is not enough information. Defend your answer, please. What do you think? Which one of those is the right one? Add what you got, Fred. Okay. So you're saying that the wavelength and frequency are not, basically we just don't know, is that what you mean? Okay. So we're not really, these are not known. Do you guys agree with that fact? What Ad said, that the wavelength and frequency of A and B are not really known? Yeah, and let me clarify, because it's a really good point, actually. So the waves that we have up here, we didn't really define this, but I want to just put it out there because it's come up. These waves here are what we call pulse waves. It's just one pulse. And when you have a pulse wave, like the width of it kind of matters, but it doesn't have a frequency because it's only one time, right? So frequency is like cycles per second. This doesn't really have cycles, it just has it's a one-time deal, right? So I totally agree that wavelength and frequency are not known. You're saying speed is equal to wavelength times frequency. So we don't know, right? Like shoulders up emoji, but what were you gonna say? There. Okay. So everybody kind of is in agreement here, but then Haley, you're saying that if it's the same medium, that the speed is going to be the same? I can't write. There we go. What do you guys think about that? Agree? Grace, was that you? Okay, because it kind of came from that. And last year I had somebody that was like, I agree with myself. Like, it was did Haley say, yeah, I agree with myself. Sure. Yeah. Same medium, same speed is the same, and the same speed. That is true. That is a true statement. If you have a type of wave that's going through a medium, whether it's a sound wave or another kind of mechanical wave, like something, going through a spring or a string, like on an instrument, if the string is the same, if the spring is the same, if the air is the same, it doesn't matter what its wavelength or frequency is. It doesn't matter if it's a pulse or a periodic wave. It will have the same speed. Okay? That kind of makes sense? So the frequency and wavelength don't really matter. Let me throw this out at you just to kind of get this in your brain. Imagine that you're in the auditorium and you've got somebody playing a piccolo and somebody playing a tuba. You guys know what a piccolo is? Tell me about the sound coming out of a piccolo. It's a little tiny, and when I make that noise, I imply that it is a high pitch, right? It's a very high pitched instrument. Okay? A tiny flute, yes. It's like a little tiny baby flute that plays even higher than a flute does. And a tuba, does a tuba play as high as a piccolo? No, it's very low. Okay? Which means that their frequencies are very different. If you're sitting in the very back of the auditorium, which one do you hear first? When the conductor goes da, and they both play at the same time, so at the very same moment, they're gonna play at the same time. Which sound wave gets to the back of the auditorium first? Piccolo, tuba. What'd you say? Why? Same medium, same kind of wave, same speed, right? I clap, I snap, I speak, it doesn't matter. All of those sound waves are going to travel the same speed to your ears, okay? Same. How are we doing? Are we okay? All right. Next thing that we're going to do, you're going to pull out this sheet. Can I steal this from you for a second? Everybody has one of these lovely green sheets, and you've taken notes on about 2/3 of it, maybe a little more, 3/4 of it. But I don't know if you remember, there was a bottom that never got done. So pull that out. If you need one because you don't have one, you lost it, whatever the case, let me know and I can hook you up. I've got some right up here. anybody need one? He's working on some stuff in the back. You miss him?
Yeah.
You like it better than me, I get it.
No, that's not what I meant.
Does anybody need one?
I can be down here.
I'm just kidding. We all good? All right. So it's been a while. I'm going to give you 1 minute. 1 minute right now with your table mates to discuss that bottom part. Now, it may be that you haven't filled in and you just got to like compare. It may be that you don't know. And even in that case, you can read it and you can use the context to fill it in. Okay? 1 minute. Have a conversation right now with your table. Go, go, go. Get as much of it filled in as you can. Go do your thing. Not a good one. All right, my friends. Here we go. This is a lesson in context clues, right? Sometimes you know answers to science questions or to other questions, whatever topic it is, and sometimes you don't. And either way, you can use the smarts in your brain to figure this out. Here we go. Unlike matter, there's a key there, right? Unlike matter, waves can or cannot occupy the same space at the same time. Well, if you don't have any idea, can matter occupy the same space at the same time? Can you have two objects that are at exactly the same spot at exactly the same time? Resounding answer was what? No. I said it too, didn't you? Yeah, she did. No is the answer. So, given that and knowing that it's unlike matter, waves what? What's the answer there? Can. Holy cow. It's amazing, you guys. Waves can indeed occupy the same space at the same time. That's great. When two waves meet, we're reading this together. Your pencil's out. You're actively learning here, you guys. They undergo, this word's in bold. It's important. I would underline it. I'd get out my highlighter. This is glitter pen time. This is what I'm talking about. Everybody's paying attention. Awesome. All right. The word is superposition. Yes. They undergo superposition. It's an important word, in which the total amplitude of two or more waves in the same space is the blank of their individual amplitudes. What do we think it is? The sum. We're going to add them together. We're going to add them together. Remember I told you that the equations in this stuff was not going to be very hard. We're just adding stuff together. It's the sum of their individual amplitudes. It is important to note that this combination occurs only for an instant. My friends in the back. Also known as blank. It starts with an I. Anybody know it? Interference. So the word superposition and the word interference for all of our purposes are essentially the same thing. Superposition, interference, it's the same deal, okay? It occurs only for an instant. That's important. And the next part of the sentence is also important. It says, and then the waves continue to travel in their respective directions unaffected. I'm going to underline that. You might want to highlight that. Again, if you have your glitter pens out, this is the time to use them, okay? Well, you could get them out if you have one, okay? That's sad. Bring them next time. Okay. In their respective directions unaffected. So that means that if Ryan is talking and I'm talking at the same time, and his sound wave is coming this way and mine is coming this way, then indeed Cole can still hear me, even though Ryan's sound wave gets in the way of mine. You with me there? Do you see what I'm saying? Okay. His sound wave and my sound wave occupy the same space at the same time. They indeed can. And at that moment where those two waves interact, then holy cow, there's going to be some superposition. But after they interact, Ryan's wave's just going to keep on going. My wave's just going to keep on going as if nothing ever happened. They don't destroy each other permanently, just for a moment. All right. We generally can separate this phenomenon, this interference idea, into two types. So there's one that's here and then one that's labeled here. Destructive, and the opposite of destructive, does anybody know what that one is? Constructive, yeah, it is. So constructive interference is when the disturbances are on the same side of equilibrium. Do you guys know what I mean when I say equilibrium? So like if I've got a wave and it's going like this part right here is equilibrium. That's where the wave wants to be. And this is on, like, I would say, like above the equilibrium, okay? So if I've got two waves that are on the same side of equilibrium, it results in an increase in amplitude. Given that, I'm going to give you 1 minute. I want you to write down the definition for destructive, okay? Everybody do it right now. Go ahead and write. So, physicists, I want to challenge you in the next few weeks not to just rely on myself or Mr. B to tell you answers, okay? Please put your phones away. You do not need your phones. Like, put them, like, you don't even need them out. Like, put them, no, like, away. Like, not on the table, in your bag or in your pocket, or like, put them away. You don't need them right now. I feel like sometimes we get a little bit lazy. You're like, oh, she's gonna write it up here. So why do I need to write it down? I'll just write it when she writes it. Here's the thing. As much as I love you guys, I can't follow you around for the rest of your lives. And here's the thing. When you go to college or you go to career or whatever it is that you're gonna do, they're not always gonna tell you the right answer. You're gonna have to figure it out. And so you need to challenge yourself now to do that and to trust yourself and be okay with making a mistake. Because if you're not okay with making mistakes now, then you're not going to be when you get older, and that's going to be hard. And there's not going to be anybody there to catch you and help you. Okay? I'm here to help you, but I'm not here to just feed you stuff. You need to be able to do it and be willing to do it. Okay? Let's figure this out. I told you that constructive and destructive are what? They're opposites. So we're going to look at the definition for constructive. When the disturbances are on the same side of the equilibrium. What's the opposite of that going to be, you guys? On opposite sides, yeah. You know this stuff. You are absolutely smart enough to get this. Trust yourself, okay? When the disturbance, thank you. Are on the opposite side. And there's more to the definition. It's not just that. That tells you when destructive interference is going to happen. What's the result of destructive interference? Resulting in a, write it down, please. Use your time right now. Resulting in a, what'd you say here? Decrease in amplitude, yeah. Okay. If we didn't have a quiz today, I would take you out in the hall and we do this all together, but we are gonna do the quiz because I don't have time not to. So I'm gonna show you just a couple quick videos of this. Don't put this stuff away because you need to write some stuff down still. We're not done. Your brain is still on. You need to stay with me, friends. Okay? You need to know this for tomorrow. So take a look here. Tomorrow we're gonna start a lab, right? And you need to understand this, so we've got some definitions. So when one can't go out in the hallway, one finds a video on YouTube. So here it comes. So take a look. So we've got a slinky or a big spring, got two waves coming towards each other. There it goes. Okay. We're gonna do that again because I want you to see it. And I want you, the nice thing about the video is that we can stop it partway through. So here it comes. One wave coming from the left, one wave coming from the right. Okay, we're gonna take a look right now. So I got this wave on the left and a wave on the right. The one on the left is going to the right, we know this. How does the amplitude of the one on the left compare to the amplitude of the one on the right? It's a little bit bigger, right? This one's a little bit more than 2, and this one's a little bit more than 1. You with me there? Do you see like the lines is like 0, 1, 2, 3? Yeah? Okay. They're both on the same side of equilibrium. And then watch what happens. Right? Now we've got totally constructive interference. Same side of equilibrium, they interact, and their amplitude is about 3, which shouldn't surprise us because we had a 2 and a 1. Yeah? And then this is the part that's super important. Where's the big one now? It's on this side. So that big wave that started on the left just keeps moving to the right. Are you with me here? And the one on the right just keeps moving to the left. I'm going to give you a couple quick pictures. I want you to draw this in your notes. So this can be in your notes, or this can be on your green sheet. I don't care, but I want you to draw these pictures right here. 1, 2, 3. There they are. Okay? This is constructive interference. So you got an amplitude of about 2, you got an amplitude of about 1. They're moving towards one another. In that second picture, they're interacting. You can see that the result, it's also called the resultant, okay, is about a 3. That happens just for a moment. And then the amplitude of 2 is now moving this way. So it's going to be a different color. And the amplitude of 1 is over here, okay? And they just keep on trucking. Okay? I'm going to save the destructive one for tomorrow. Will you guys remind me that we have not watched that one yet? Okay? What I would like you to do right now is to put everything away. You're going to need a calculator out and a pencil. I'm going to give you some assessment seats in just a moment here. So sit tight for just a sec. You need a calculator and pencil out.